Hello, Namaste, welcome back to my channel. I am Ramya. Today we are going to mix logic with programming and solve one of the most popular puzzles in the world, Sudoku. Sudoku is a 9 by 9 number puzzle that improves focus, sharpens your brain, and is super satisfying to solve. In this video, I'll show you how I wrote a Sudoku solver in three programming languages, Python, Java and C. We will also see how the same logic looks different in each language. First, here is the unsolved Sudoku we are going to work on. Our goal is to fill every empty cell, so each row, column and 3 by 3 box contains the numbers 1 to 9 exactly once. The heart of our program is called backtracking. It works like find an empty cell, try numbers from 1 to 9. If a number follows Sudoku rules, place it and move to the next cell. If you get stuck, go back, backtrack and try a different number. Repeat until the board is complete or no solution exists. This logic is the same in all three languages. Alright, let's go through the Python code step by step. At the very top we see D of is safe, board, row, column, number. The keyword D of in Python means we are defining a function. This function checks whether a number can be safely placed in a given row and column of the Sudoku board. Inside it, the first line, if number in board of row, quickly checks if that number already exists in the same row. Then we have a loop that scans the whole column and another double loop that scans the 3 by 3 subgrid. If the number is not found in any of these places, we return true, meaning it's safe to put it there. The next function is solve Sudoku board. This is the backtracking algorithm. We loop through each and every cell in the 9 by 9 grid. When we find an empty cell, that's a 0. We try all numbers from 1 to 9. If a number passes the is safe check, we temporarily place it and call solve Sudoku again. If the puzzle can't be solved from that point, we reset the call back to 0. This is called backtracking and try another number. If we reach the end without empty cells, we return true, meaning the puzzle is solved. After that, we have print board of board, which is just a helper to display the Sudoku nicely. It prints each row, joining the numbers with a space so it looks clean. Finally, at the bottom there is a special line, if name equals to main. This means only run the following code if this file is being executed directly, not when it is imported somewhere else. Under that line, we define our Sudoku puzzle as a list of lists. Zeros represent empty cells. We print the unsolved Sudoku, call the solver, and then print the solved Sudoku board or a message if no solution exists. Let's move on to Java. At the very top, we have public class Sudoku solver. In Java, everything lives inside a class. Then we define our first method. Public static boolean is safe int board int row int column int number. It checks if it is safe to place a number at a particular cell, just like in Python, but here we specify data types like int for integers and boolean for true or false. The solve Sudoku method is almost identical to the Python version. Loop through the cells, try numbers from 1 to 9, call itself recursively, and backtrack if needed. Because Java is more structured, we use curly braces and return statements clearly. Next is print board, which loops over the rows and columns, printing each value with a space. The main method is where everything starts in Java. We create a 9 by 9 int array with the Sudoku puzzle, print the unsolved board, run solve Sudoku, and finally display the solved board or say there is no solution. Now for the C, at the very top of the file we write hash define n9. The hash define is a preprocessor directive that tells the compiler wherever you see n, replace it with 9. This makes it easy to change the size later. We also include header files. Hash include stdio.h for input and output, and hash include stdbool.h, so we can use the keywords true and false. Our isSave function takes the board, a row, column and a number. It loops through the row, column and subgrid to check if the number is allowed. The solve Sudoku function is again the same logic. Find an empty spot, try numbers and backtrack. Because C doesn't have built-in lists, we use a fixed 2D array. Print bird just prints each element, adding spaces to keep the layout neat. Finally, in main method, we declare the Sudoku puzzle as a 9 by 9 array. Print the original board, call the Sudoku solver and print the solution if it is found. And that's how I solved Sudoku in Python, Java and C using backtracking. I hope you enjoyed learning how the same algorithm looks in different programming languages. If you liked this video, please give it a thumbs up, subscribe to my channel and press the bell icon so you don't miss upcoming videos. Comment below which language you found easiest or most interesting. Thank you for watching. Keep coding, keep solving puzzles, and I will see you in the next video. Bye bye.